You can float a rubber duck in a bathtub. Simple. But how do you lift something heavier than the Titanic straight up into the air using nothing but water? No pumps, no hydraulics, no engines, just gravity. The Panama Canal does this every single day. It raises 53,000-ton ships, 26 meters above sea level, moves them across an artificial lake, and lowers them back down on the other side. And every time it does it, 200 million liters of fresh water get dumped into the ocean. Gone. That's not a typo. 200 million liters per ship, every single transit. So how does water lift something that heavy? Why does the canal sit above sea level in the first place? And what happens when all that water runs out? The answer starts with a catastrophic failure over a century ago that killed 20,000 people, and a brilliant decision that came after it. Here's the thing most people get wrong about the Panama Canal. They picture a giant trench, a straight line carved from one ocean to the other, water flowing through, ships sailing across. Flat, simple, done. That was actually the original plan. In 1880, the French showed up to build exactly that. A sea-level channel cut straight through Panama, no elevation changes, no locks. It was supposed to be the next Suez Canal. It was a disaster. The jungle fought back with everything it had. Landslides buried months of progress overnight. Tropical diseases, mainly malaria and yellow fever, tore through the workforce. Torrential rain flooded dig sites faster than crews could drain them. Over the course of the project, 20,000 workers died. 20,000. The French eventually gave up, went bankrupt, and walked away from the whole thing. Then the Americans took over. And here's where the genius move happened. Instead of trying to finish the French plan, they threw it out completely. Their engineers looked at the terrain and made a totally different bet. Don't dig down to sea level. That's what killed the French. Instead, remove part of the mountains, dam up a major river called the Chagres, and flood an entire valley to create a massive artificial lake sitting 26 meters above the ocean. That lake is called Gatun Lake, and it became the canal's highway. Ships don't sail through a trench at sea level. They get lifted up to the lake, cruise across it, and get lowered back down on the other side. That elevation change is the entire reason the lock system exists. No lake, no locks. No locks, no canal. Every single thing about how the Panama Canal works traces back to that one decision. Forget the trench, flood the valley, build locks, and it changes everything about what happens next. Now here's the part that breaks most people's brains. How do you actually lift a 53,000-ton ship using water? No cranes, no hydraulic pistons, no massive engines pulling it upward. The answer is so simple, it almost sounds fake. Water flows downhill. That's it. That's the entire system. Here's how it works. A ship enters a concrete chamber, basically a giant bathtub with gates on both ends. The gates close behind it. Then operators open valves in the floor of the chamber, 100 openings built into the concrete. On the other side of those valves sits Gatun Lake, 26 meters above sea level. Because the lake is higher than the chamber, water naturally flows down into it. No pumps needed. Gravity does the work. 80 million liters of water pour in over 8 minutes. As the chamber fills, the ship rises with it, the same way your body rises in a bathtub when you leave the faucet running. One fill lifts the ship about 8 meters. Then the forward gates open, the ship moves into the next chamber, and the whole thing repeats. At Gatun, there are 3 chambers stacked in a row. Each one lifts the ship another step. After all 3, the ship is sitting 26 meters above where it started, level with the lake. It sails across and reaches the other side. On the Pacific end, the process runs in reverse. Water drains out of the chambers, and the ship lowers step by step back down to sea level. Same physics, same gravity, opposite direction. No engines, no fuel, no mechanical lifting system of any kind. The most important trade route on the planet, a corridor that moves 172 million tons of cargo every year and generates $2 billion in tolls, runs on the exact same principle you learned in a third-grade science class. Water finds its level. It flows from high to low, and if you build the right container around that flow, it can lift just about anything, even something heavier than the Titanic. So the physics are elegant, beautiful even. Water flows in, ship goes up, but here's where elegance meets terror. The ship entering that chamber is 32 meters wide. The chamber itself is 33.5 meters. That leaves less than a meter of clearance on each side, less than the width of your arm. Now stretch that problem lengthwise. The ship is 300 meters long. The lock is 320 meters. That's 10 meters of breathing room on a vessel longer than 3 football fields. This is the equivalent of parallel parking a skyscraper into a swimming lane, except the skyscraper weighs 53,000 tons and is carrying 66,000 tons of cargo behind it. One wrong move and the hull breaches. One wrong move and the lock wall cracks. If the lock is damaged, the Panama Canal shuts down. And here's the part that makes it even more intense. The Panama Canal is the only place on Earth where a ship captain is legally required to hand over control of their vessel. A canal pilot takes command. These pilots train for 8 years before they're allowed to guide a ship through. 16 years of experience isn't unusual, and even then, the pressure is enormous. The pilot steers from the bridge, which sits more than 220 meters from the bow. That's like driving a car from the back seat with the windshield blacked out. Tugboats push the ship into position at the lock entrance. Then specialized operators throw lines to attach steel cables to the bow and stern. Those cables connect to 50-ton locomotives called mules that run on rails along both sides of the lock. Each mule can tow 32 tons and costs $2 million. Their entire job is to keep the ship centered as the chamber fills. And that centering matters more than anything. When 80 million liters of water rush in through the floor, it has to flow evenly. If turbulence kicks up, the ship could slam against the concrete walls. Or worse, snap the half-ton steel cables with enough force to cut a person in half. Elegant physics. Terrifying execution. But here's the problem nobody talks about. Every time a ship passes through the locks, the canal bleeds. Not metal, not concrete. Water. Fresh water. 200 million liters of it. Gone with every single transit. That water flows out of the lock chambers and drains straight into the ocean. It doesn't come back. It's not recycled. It's not pumped back up. It's just gone. Now multiply that by the traffic. Up to 40 ships pass through the canal every day. That's roughly 7.5 billion liters of fresh water consumed daily. Not spilled accidentally. Consumed by design. The lock system can't work without it. Every time water fills a chamber to lift a ship, that water has to go somewhere when the next chamber opens. It flows downhill toward the ocean, exactly the way gravity intended. The system that makes the canal brilliant is also the system that slowly drains it. And all of that water comes from one place. Gatun Lake. The same artificial lake the Americans created when they dammed the Chagres River over a century ago. The lake is the engine. It feeds every lock on both sides of the canal. Without it, nothing moves. So how does the lake survive losing billions of liters a day? The Chagres River. Rainfall in the surrounding watershed feeds the river feeds the lake, and the lake feeds the locks. It's a cycle, and as long as enough rain falls, the cycle holds. But here's the tension. Rainfall isn't guaranteed. Drought years squeeze the supply. Climate variability shifts the pattern, and traffic through the canal keeps growing. More ships means more transits, More transits means more water consumed, and the lake doesn't get bigger just because demand goes up. The dam that created Gatun Lake also powers a hydroelectric plant that runs the entire canal operation. So the same water supply fuels the locks and the infrastructure. One resource doing two jobs, and both jobs get harder when the rain doesn't come. The brilliant solution came with a built-in cost, and that cost compounds every single day. Now let's put you inside the transit so you feel how tight the clock really is. A container ship enters from the Caribbean side at Lyman Bay. It left Israel 3.5 weeks ago, carrying containers bound for China. The Atlantic is behind it. The Pacific is 80 kilometers ahead. And between the two sits the most complex shortcut on Earth. The ship has 8 hours of daylight to make it through. Sailing the canal in the dark is too dangerous, so if the ship doesn't clear the Pacific side before nightfall, it's stuck. No extensions, no exceptions. The first hour covers 11 kilometers of approach channel before the ship reaches Gatun Locks. This is where the heavy lifting happens. 3 chambers, 3 rises, 26 meters up. Cables attach. Mules engage. Water floods in. The ship climbs to Gatun Lake and the locks release it. Now it crosses the lake, a 431 square kilometer body of fresh water, one of the largest artificial lakes ever created. But the easy stretch doesn't last. The ship reaches the Culebra Cut, and everything tightens. This 13-kilometer channel was blasted straight through a mountain range using massive amounts of dynamite. 6,000 workers built it under constant threat of landslides. It's the narrowest part of the entire canal, and the pilot has to thread the ship through without room for mistakes. After 3 hours in the cut, the ship exits and immediately faces the final locks, Pedro Miguel and Miraflores. These two lock sets work the same way as Gatun, but in reverse. Water drains out, the ship lowers step by step, and 26 meters later, it's back at sea level on the Pacific side. 8 hours, 3 sets of locks, 1 lake, 1 mountain pass, 80 kilometers. Done. Ships pay over $500,000 for this crossing because the alternative is an extra 20,000 kilometers around South America, 14 more days at sea. 14,000 ships a year make this same transit, moving 172 million tons of cargo and generating $2 billion in toll revenue for Panama. 8 hours that replace 2 weeks. Here's the part that makes this personal. You've been on the receiving end of the Panama Canal your entire life without knowing it. That container of electronics you ordered online that shipped from Asia to the East Coast? It almost certainly passed through those locks. The raw materials in the car you drive, the parts in the appliances in your kitchen, the fuel that heats your home, a massive share of it moved through an 80-kilometer stretch of water in Panama. Over 1 million ships have used this canal since it opened in 1914. 1 million. And the route is over 100 years old, but it's not a museum piece. It's not a historical curiosity you read about in a textbook. It's active infrastructure running at full capacity right now. 36 ships a day, both directions, 450,000 tons of cargo every 24 hours. The canal isn't something that happened. It's something that's happening. And every transit still works the same way it did a century ago. Water flows in, ship goes up. Water flows out, ship comes down. No pumps, no engines. The same gravity, the same lake, the same concrete chambers. Still working, still essential. Still feeding the global supply chain you depend on every single day. So here's where you land. You started this thinking the Panama Canal was about brute force. Giant machines, massive engines, impossible weight being shoved upward by raw power. But the answer is water flowing downhill. A group of engineers over a century ago looked at a jungle that had already killed 20,000 people and made one decision that changed everything. Don't dig down, flood up, build a lake, let gravity do the lifting. And that single idea turned into the most important shortcut on Earth. 1 lake, a few concrete chambers, 200 million liters sacrificed per ship, and the simplest principle in physics. That's how you move 53,000 tons, 26 meters, into the air. No pumps, no engines, just water finding its level. That hum of global trade you never hear? It runs through Panama. And if you think the locks are impressive, wait until you see what happens when the water starts running out. Don't forget to subscribe.